This is the third video in the Secure Application series. When it comes to application security, it's safest to take a defensive posture. Sophisticated attackers with considerable resources can use these powerful techniques to gain access and compromise your credentials. If you look at the top 10 web hacking techniques of 2018, many times each technique is based on server-side request forgery and XML identity injection. If an attacker is able to penetrate your security group, they can gain access to your STS credentials using SSRF and XXE. We can mount robust defenses against these types of attacks when we have a simple setup. As the complexity of our setup increases, then our vulnerability also increases. AWS is a service that undergoes continuous innovation. A good example of this is their new Fargate service, and you can create a container rig on Fargate very efficiently. 4 years ago, the services available on AWS were smaller in number and simple in their configuration, and this simple was a keynote of the naming of these services, such as S3, the simple storage service, etc. Contrast to today, where we have approximately 100 services, and we can't ignore this innovation. Just as AWS gained a huge commercial advantage by adopting technologies such as recommendation engines before anyone else, we also need to take advantage of the commercial opportunities these innovations provide. The simple goal of these applications is to 1. Wrap an AWS SDK, then use that wrapper to manage complexity. So as we pointed out, we have many different services that we need to manage. We can manage these services effectively from the CLI, but that requires us to remember all the CLI commands for many different services. The GUI can then automate these commands to drive the SDK, focusing on a logically cohesive set of commands. AWS provides industry best practice for security, industry best practice services that are completely free to enable you to implement best practice security in your applications. This is the AWS Security Responsibility Schema, which is delimited into 2 core domains for the customer and for AWS itself. In the customer domain, the responsibility for encryption and data integrity. We focused in the last video on how you can implement this client-side and server-side encryption. Cloudtrail Monitor is part of a defensive posture. So we fulfilled our client-side responsibilities under the shared responsibility model, but we're assuming we're being hacked anyway. We're going to take extra preventative measures and monitor in real time the use of our credentials and hopefully detect the use of compromised credentials. An unused service or an unknown IP is using our credentials. That will flag an alert. The information in the Cloudtrail event will then allow us to quickly delete the compromised credentials, shut down the resources that have been created with those credentials, and we can do that quickly while we negotiate with AWS. Code we are previewing here is a user interface wrapper for the Cloudtrail SDK that was put together with the DSL from TornadoFX. The code runs in the browser by using Scandex JPro. We have our SDK wrapper applications that are using IAM user credentials, and we have our remote AWS services, instances and containers that are all using STS credentials. We are assuming that these credentials can be hacked, so we're monitoring the use of these credentials, and we will hopefully detect when the credentials are compromised. The application runs in a container behind a firewall and is deployed to the user in a browser. Now we will demonstrate the processes involved. So we start by building a Docker file. JPro can be difficult to set up, and it's strongly operating system kernel dependent, so it's a good candidate for containerization. In this Docker file, we are just running the code from source with Gradle, but our environment is set up correctly. So once the container's booted up, we will demonstrate the application running. Now the JPro server is initializing, and now it's listening on port 8080. It's very convenient to deploy the code in a browser with JPro like this because it makes it very operating system independent. We only care about the browser environment. So we just have a simple login process with a hash, strong 512 hash. So we will enter our password and our paraphrase, once again for in-memory key store, just as before. And it first presents with no data because we need to set up our scheduling. How often will we call out to refresh the Cloudtrail data? So we'll choose a 15-minute repeat. Now we have the results. We can select an IP by selecting on a row in the table. We can construct an IP whitelist by entering IPs. We have some filtering options. We can filter on event type, or we can filter by allowed IPs. So when we select an IP in the whitelist, we don't display it in the table. We whitelist an IP group, then if we see IPs appearing, we know they're not our IPs. So this is how we can construct alerts. Here we are showing we're filtering on an IP, so that IP is not displayed. This is just a prototype. This can be easily extended with more complex filtering operations. It's possible to write very clean code in Kotlin that you can easily extend to a high level of functionality. We can log out at any time and log back in. We have basic validation on the login process. We create a basic SDK client and then we create a lookup event request. This requires a time interval. The API returns by default 50 results, and the maximum result set is of size 50. Scandex JPro requires Java 11 to run. This means we need to configure a number of Gradle plugins. It's a bit tricky to set them up. Some of the plugins are in the standard Gradle repository, so we can use the new syntax, but some are not there yet, so we require a mix of the old and new plugin syntax. Out of the box, TornadoFX does not work with Java 11 unless you use the latest snapshot, which is only available from the Sonatype snapshot repository. So it's a bit tricky to configure everything for Java 11 and all the plugins required. We use standard JSON to serialize the JSON types. So we have types that we've created to wrap the Cloudtrail event. We also have types that we've created to do bindings in the grid and other parts of the user interface. So we can bind the data that we've serialized from the JSON from the API to display it in the GUI. Because the browser as a client is single-threaded, there are some limitations on what you would think of as typical Kotlin code as regards threading. But we have some artifacts from JavaFX we can use to get around the single-threaded nature, particularly for scheduling. So rather than using your typical executor service, here we are using a Java animation type called a timeline to implement the scheduling that will refresh the grid with new data according to our scheduling scheme we've selected. And this will all happen without pausing and happen on the GUI thread. Another JPro related issue is we cannot use this as a multi-document interface. We only have one view in the browser, so we can't use our typical alerts and pop-ups we would use in JavaFX. What we need to do is use this internal TornadoFX artifact they call an internal window. The internal window will create a pop-up-like view that's attached to a node that we observe. So we have one here called an internal list view, and that allows our selections of the whitelisted IPs or the event types. TornadoFX gives us a lot of attributes out of the box, such as the ability to create async processes with very small blocks of code. TornadoFX is a well-designed DSL that implements a number of features that allow you to quickly and easily implement view designs. Here we're looking at a fragment. This is equivalent to giving a Spring Bean a prototype scope. When we implement a class extends view, creates a typical singleton you would expect.